I'm Dr. Harriet Burge, Director of Aerobiology for EMLab P&K. I'd like to talk to you a bit about our mold range, which is derived from a large data set of outdoor air samples, more than 100,000 samples. As most of you know, we're swimming in a sea of fungi. All the fungi that grow indoors that have come in originally from outdoors. There are no indoor fungi. There are no fungi that evolved in the indoor environment. The indoor aerosols depend very strongly on the outdoor aerosols, even in buildings where there's significant mold growth in the indoor environment. Most fungal exposure, though, even if you have a moldy environment that you're living in, most fungal exposure occurs outdoors. And most people who are sensitized to fungi became sensitized by exposure to outdoor aerosols. This slide shows you the correlation, the strong correlation that is present between indoor and outdoor aerosols. And this is a variety of places, not just variety of homes, not just ones that are clean. There are included in this slide are homes that did have mold growth in them. The next slide shows you the outdoor aerosol, just to give you an idea of what can be out there. This is a sunny day aerosol, and you can see many, many spores in this slide, most of them brown. This is a melanin pigment that's designed to protect the spores from ultraviolet light. You can see that there are many, many different kinds of spores on this slide, and lots of little ones that probably are mostly cladosporium. That's our most common spore type in the outdoor air. This picture represents a concentration of probably as many as 100,000 spores per cubic meter of air. So we're not talking about 200 or 400 or 1,000. We're talking about tens of thousands of spores in the outdoor air. The next slide is also the outdoor air, but in this particular case, it's been raining. And all the little rod-shaped spores that you see here are ascospores, and they are wet spores that are either splash dispersed or released from their fruiting bodies by the action of the rain. The next slide is also the outdoor aerosol, and this is early in the morning when the mushroom spores become abundant, basidiospores become abundant in the outdoor air. So think about this. You get up in the morning, you go out, you collect a sample early in the morning, and the highest concentration is of basidiospores. And these may be in very, very high concentrations too. I've seen them in concentrations as high as 500,000 spores per cubic meter of air. Let's say about 10 o'clock in the morning it starts to rain. The basidiospores are essentially gone by then, but now the ascospores are splashed up into the air and are released in huge numbers, and the aerosol changes completely. Within 10-15 minutes, the whole aerosol changes and becomes an ascospore-dominated aerosol. At about noon, the rain stops and it becomes really hot and sunny and the wind picks up. All those rain-produced spores disappear from the air, and the dry brown spores appear again in very high concentrations. So here you have three different populations of outdoor spores that just depend on what was going on with the weather on that particular day. So we know that the outdoor aerosol changes minute by minute. It changes seasonally, so that if you live in Minnesota, for example, and you have 6 to 8 inches of snow on the ground, or a foot or 2 feet, you'll have very few spores in the outdoor air. And in fact, sometimes during those conditions, you can avoid taking outdoor samples at all because they're not going to be really useful to you. If you live in California, on the other hand, some days you have 24/7, you have spores in the air. Some days you have we have air that it blows in off the Pacific Ocean, thousands of miles of water with no spores at all. Other days we have our wind coming from the San Joaquin Valley, which is a big agricultural area and which has an abundance of spore aerosols. So we need to know in our area what way the wind is blowing and so forth. So seasonal variations are not important to us, but the geographic variation where we live is very, very important. So these are some of the factors that influence what's going on in the outdoor aerosol that you're attempting to sample in just 5 minutes of sampling time on a single occasion. So what can we do about that? Well, we can look at guidelines, if there are any guidelines out there that tell us what's low, medium, and high, and the American Academy of Allergy, Asthma, and Immunology has published these guidelines for you. Unfortunately, the data was collected using a whole variety of different kinds of samplers. The samples were all analyzed by people who may or may not have been trained. There are as many analysts as there are stations, and most of the samples are collected in the growing season. So they essentially ignore all those times of the year when there are zero spores, or essentially zero spores, in the outside air. EMLab P&K has collected a very large data set consisting of more than 100,000 samples of fungal aerosols collected by our clients, using virtually the same sampling approach, same sampler, in fact, and the same sampling times between 5 and 10 minutes. And all of the samples were analyzed by EMLab P&K's experienced and certified spore counters. This is a slide that shows some of that data. This is Penicillium across the entire country by date. And you can see the huge variation. Penicillium is a really interesting fungus because most people feel that it's an indoor fungus. You can see here that there are a reasonable number of events in this database. And by the way, this isn't 100,000. This is more like 10,000 that it was all that would fit in my computer file. But you can see that there are a significant number of days where the levels are certainly above 1,000 outdoors, and even as high as 10 to 50,000 outdoors. So Penicillium is not an indoor fungus. It's an outdoor fungus that occasionally grows on indoor materials. The next slide shows you Penicillium, the same data from 2 states, from Southern California and from New York. And you can see the difference in the pattern over time of these spore aerosols. Because we have so many samples now, we can further analyze our data, and we're doing that by zip code. So in the near future, you can receive data based on the zip code that you're actually sampling in, or at least a group of zip codes that represent your area ecologically with respect to the fungi, and the date that you're sampling on, or at least within a short period on either side of that date. This will improve your ability to use the MoldRANGE to compare with your own outdoor sample. This is a check. These MoldRANGE is meant to be a check on the validity of your outdoor sample. It may help you avoid errors. For example, if there's very, very low concentrations of, let's say, Cladosporium outdoors and relatively high concentrations indoors, you can look at the MoldRANGE and you'll see perhaps that the level that you got in your sample is at the very bottom of the range that Cladosporium would be in at that time of year. And so it's very possible that what you're seeing indoors came from yesterday's population of Cladosporium, which may have been closer to the average for your particular area. Another problem is if you have very high levels of outdoor spores, like Basidiospores indoors, and none outdoors, you may consider that that you have a source indoors for Basidiospores, which is really unlikely. There are a few cases, but mostly it's unlikely. In this case, you again look at the MoldRANGE and you find out that the range for Basidiospores doesn't even include the 0 that you found on that particular day. And in fact, you would expect on most days to have much higher levels. And this will allow you to avoid the error of saying that you have a contaminated environment with Basidiomycetes, which is unlikely. All of our statistical aids are meant to be used by experienced investigators and are not to be used alone for the interpretation of data. All the decisions about sampling data must be made by the person who actually collected the samples and was on site looking at the conditions in the space and using their experience. Thank you.